Railway lines 25-meter long are being laid when the temperature is 15 degrees Celsius. Gaps of 1.8 centimeter are being left between them. At which temperature will they touch each other? Given the coefficient of linear expansivity is 1.2 times 10 raised power minus 5 per degree Celsius. A, 55 degrees Celsius. B, 50 degrees Celsius. C, 75 degrees Celsius. D, 110 degrees Celsius. Now, for those of us who have observed on rails, there are gaps between the rails that are being left by the constructors. This is because of what? Linear expansivity or area expansivity, because this is real life, so we deal with area, not linear expansivity. So the area expansivity of these lines is okay. This is due to the area expansivity of these lines. That is why these gaps are being left, right? In the afternoon, when the sun is very hot, the lines will expand and touch each other, while in the evening it will contract and then the gaps will be left again. This is done because in order to avoid bulging of the lines. Without these gaps, area expansivity, volume expansivity will cause bulging on the lines in the future. So to avoid this, they leave these gaps so that when it expands, it touches, and then when it contracts, it leaves the gap again. So this is what the question is referring to. We know that linear expansivity is given by the change in length all over the initial length multiplied by what? The change in temperature, right? In this case, what do we have? We have L1 to be 25 meters. And then we have, okay, we don't have L2, but we know that L2 minus L1, which is the change in length, is what? 1.8 centimeters, which is equal to, we have to change this back to meters. Divided by 100, we have what? 0.018 meters. What else do we have? Theta 1 is what? 15 degrees Celsius. We are supposed to change this to Kelvin, but notice that our answers are in degrees Celsius. This is also in per degree Celsius, so we can solve it using this. Theta 2 is equal to, that's what we're looking for. So can I make theta 2 the subject of the formula here? I can change this to, okay, let's just substitute and see what we have. This will be equal to what? L2, L1 bracket what? Theta 2 minus theta 1, because that is what this change in theta means. So I can write this as what? Alpha equal to change in L over L1 theta, change in theta. So change in L is equal to what? Alpha times L, or let me just write alpha L1 change in theta. So we can use this now to get our theta 2. What is change in alpha? We have 0.018 equal to 1.2 times 10 raised power minus 5 times L1 is 25 bracket theta 2 minus, what is theta 1? 15 degree Celsius. So clearly from here, I can write this as what? Theta 2 minus 15 degrees Celsius is equal to 1.2 times 10 raised power minus 5. No. 0.018 divided by 1.2 times 10 raised power minus 5 times 25. Right? So theta 2 minus 15 degrees Celsius will be equal to, what do we have? 0.018 divided by 1.2 times 25, We have 30. 30 times 10 raised power minus 5, which is equal to what? 0.018 divided by 30 is what? 0.0006 times 10 raised power 5. Notice that this minus 5 has become plus 5 because when it's going up, it becomes what? A positive sign. So we have what? I can write this as theta 2 is equal to minus 15 degrees Celsius equal to 60. 1, 2, 3, 4, 5. So this becomes 60, right? So theta 2 is what? 60 minus plus 15. Theta 2 is equal to 75 degree Celsius. Our answer is what? C, 75 degree Celsius.